Find electric field E bar at 034 meter due to a point charge Q is equal to 0.5 microcoulomb placed at origin. So solution, we draw the vector. This is point Q, 0.5 microcoulomb placed at origin, so it is 0, 0, 0. It is E bar 0, 3, 4. This point is 0, 3, 4. And this is vector R bar. So the vector joining, we write here the vector joining charge Q and point and the point where we desired field is. R bar is equal to, we have to find the value of R bar. It is 3 minus 0 AY bar plus 4 minus 0 AZ bar, 0 minus 0 X bar, so this term is not considered. 3 AY bar plus 4 AZ bar, so R is equal to magnitude 3 square plus 4 square, so it is square root of 25, it is 5. And AR bar, that is unit vector, it is R bar by R, so it is 3 AY bar plus 4 AZ bar divided by 5. Now put this value in expression of E bar. We are putting this value in the expression for E bar. So E bar is equal to Q by 4 pi epsilon 0 R square AR bar. So it is equal to 0.5 into 10 raised to minus 6 divided by 4 pi into 10 raised to minus 9 by 36 pi into 25. So it is 3 AY bar plus 4 AZ bar divided by 5. So we solve this and we get, it is 108 AY bar plus 144 AZ bar volt per meter. Now the next problem, find the expression for electric field at point P XYZ due to a point charge Q coulomb at point X1, Y1, Z1 using Coulomb's law of force. So we draw figure for this. This is point Q, X1, Y1, Z1. This is point Q T at P of X, Y, Z vector R bar. Now the vector joining the charge Q and point P is shown in this figure. So we have to find the value of r bar. So it is x minus x1 ax bar plus y minus y1 ay bar plus z minus z1 az bar. Next is its magnitude. So it is square root of x minus x1 square plus y minus y1 square plus z minus z1 square. So unit vector ar bar is equal to x minus x1 ax bar plus z minus z1 az bar divided by magnitude so this is unit vector. Next, using Coulomb's law, force on QT is given by Ft bar is equal to QQT divided by 4 pi epsilon 0 r square AR bar, and the electric field at point P is 4 sat that point per unit charge at that point. So E bar is equal to 1 by QT into Ft bar. So it is Q by 4 pi epsilon 0 r square AR bar. Then E bar is equal to Q by 4 pi epsilon 0 r square AR bar. So we substitute values here. It is Q divided by 4 pi epsilon 0. Value of R is x minus x1 square plus y minus y1 square plus z minus z1 square of all this, and unit vector is x minus x1 ax bar so this is unit vector. So we solve this and we get Q divided by 4 pi epsilon 0 into x minus x1 ax bar plus y minus y1 ay bar plus z minus z1 az bar divided by x minus x1 square plus y minus y1 square plus z minus z1 square. Bracket of this is 3 by 2, it is volt per meter. Now when the charge is at origin, when the charge is at origin, so x1 is equal to y1 is equal to z1 is equal to 0. So then E bar is equal to Q by 4 pi epsilon 0 into ax bar plus y ay bar plus z az bar divided by x square plus y square plus z square raised to 3 by 2. But right here this expression fails to show the symmetry of field. Fails to show the symmetry of field in spherical coordinate we know that A r bar is equal to x ax bar plus y ay bar plus z az bar divided by x square plus y square plus z square. And what is r? R is x square plus z square of square root. So we can write E bar is equal to q by 4 pi epsilon 0 r square A r bar 4 per meter. A charge q is located at origin. A charge q is located at the origin in free space produces a field for which Ez is equal to 1 kilovolt per meter at point P minus 2 1 minus 1. So first find Q, second find E bar at M165 in Cartesian coordinate. C. Find E bar at M in cylindrical coordinate. Find E bar at M in spherical coordinate. So we have to find Q and we have to find E bar at Cartesian, cylindrical and spherical coordinate. So first is to find Q. So this is vector r bar and AR bar is equal to unit vector, so it is minus 2x bar plus AY bar minus AZ bar square root of 2 square plus 1 square plus 1. So it is 4 plus 1 plus 1, it is square root of 6. Now the electric field at point P. Electric field at point The electric field at point P is E bar is equal to Q by 4 pi epsilon 0 r square into AR bar. So it is Q by 4 pi epsilon 0 r square is square root of 6 into minus 2 AX bar plus AY bar minus AZ bar square root of 6. Since the Z component is of value 1 kilovolt per meter, so we can write minus Q by 4 pi epsilon 0 6 square root of 6 1 into 10 raised to 3. Therefore Q is equal to minus 4 pi epsilon 0 6 square root of 6 into 10 raised to 3 minus 1.63 microcoulomb. So this is equation. Now next is to find E bar. Second part is find E bar at point M 165, the required vector and unit vector. So R1 bar is equal to AX bar plus 6 AY bar plus 5 AZ bar. So AR1 bar is equal to AX bar plus 6 AY bar plus 5 AZ bar divided by square root of 62. So we draw out here the vector. It is so this is point of origin Q minus 1.63 microcoulomb 0 0 0. This is R1 bar. This is M165. Now unit vector AR1 bar is equal to X bar plus 6 AY bar plus 5 AZ bar by square root of 1 plus 36 plus 25, it is 62. Now E bar at M in Cartesian coordinate. In Cartesian coordinate, it is given by E1 bar is equal to Q by 4 pi epsilon 0 R1 square into AR1 bar. So it is equal to, we substitute the values, minus 1.63 into 9 minus 6, 4 pi epsilon 0 is 10 raised to minus 9 by 36 pi into square root of 62 bar into, it is AX bar plus 6 AY bar plus 5 AZ bar divided by square root of 62. So that is equal to minus 30 AX bar minus 180 AY bar minus 150 AZ bar volt per meter. Next is C. It is find even bar. Find even bar in cylindrical coordinates. In cylindrical coordinates. So let E1 bar in cylindrical coordinates. In cylindrical coordinates B, E1 bar is equal to ER1 AR bar plus E51 A5 bar plus EZ1 AZ bar. Now cylindrical vector require, we write here cylindrical vector requires R is equal to square root of x square plus y square, that is equal to 1 square plus 6 square, it is square root of 37, that is 6.08. Phi is equal to tan inverse of y by x, so tan inverse of 6 by 1, so it is 80.54 degree. Z is equal to 5. Now from vector transformation, we have ER1 is equal to E1 bar dot AR bar, so it is minus 30 AX bar dot AR bar minus 180 AY bar dot AR bar minus 150 AZ bar dot AR bar. Now using the table of, next is using the table of dot product. We are using here the table of dot product, so it is AX bar dot AR bar is equal to cos phi, AY bar dot AR bar is sin phi, and AZ bar dot AR bar is equal to 0. So our equation is ER1 So ER1 is equal to minus 30 cos of, it is 80.54 degree minus 180 sin of 80.54 degree. So its value is minus 183.48, the ER1 value. Next we have to find E51. So it is E1 bar dot A5 minus 30 AX bar dot A5 bar is 180 AY bar dot A5 bar. So its value is minus 150 AZ bar dot A5 bar. But we have AX bar dot A5 bar is equal to minus sin phi. Also AY bar dot A5 bar is equal to cos, it is cos phi, and AZ bar dot A5 bar, its value is 0. So the above equation becomes E51 is equal to minus 30 minus sin of 80.54 minus 180 cos of 80.54. So this value is 0. Now we have to find the EZ1. So EZ1 is equal to E1 bar dot AZ bar, that is equal to minus 150 AZ bar dot AZ bar is equal to minus 150. So E1 bar in cylindrical we write here. So E1 bar in cylindrical is E1 bar is equal to minus 183.48 AR bar minus 150 AZ bar. Now the next is E1 bar in spherical coordinate. We have to find E1 bar in spherical coordinate. So equation become, equation is E1 bar is equal to ER1 bar AR bar plus E theta 1 bar A theta bar plus E phi 1 bar A phi 1 bar. This now spherical vector requires the values of r, theta and phi. So we will find the values of r, theta and phi. We write here spherical vector requires this vector requires values of r, theta and phi. So r is equal to square root of x square plus y square plus z square. So it is, its value is 7.87. Now what is theta? Theta is cos inverse of z by r. So it is cos inverse of 5 by 7.87. It is 50.58 degree. And phi is equal to tan inverse of y by x. So it is 80.54, which is calculated above. So we have now equation for ER1 bar is equal to E1 bar dot AR bar. So it is minus 30 AX bar dot AR bar, that minus 180 AY bar dot AR bar minus 150 AZ bar dot AR bar. Now using the table of dot product, we are using the table of dot product in spherical coordinate. In spherical coordinates, AX bar dot AR bar is equal to sin theta cos phi, AY bar dot AR bar is equal to sin theta sin phi, AZ bar dot AR bar is equal to cos theta. Now we are putting values of theta and phi. So ER1 is equal to minus 237.1. Similarly we can obtain Similarly, we can obtain E51 is equal to 0, Ez1 is equal to 0. This is very obvious because the charge is at origin and we expect only a radial component. So in spherical, E1 bar is equal to minus 237.1 AR bar volt per meter. Next, determine the electric field intensity produced at point 004 meter by the system of charges comprising of first one, Q1 is equal to 0.50 microcoulomb at 002 meter. Second, Q2 is equal to minus 0.60 microcoulomb at 300 meter. And third one, Q3 is 0.35 microcoulomb at 040. So first we write the given charges are placed in the coordinate system. For that we have to draw the figure. So this is z axis, y, and this is x axis. This is point Q2. Q1 is 002, Q3 is 040, and it is 300. So this point is 004. It is R2 bar. This is vector R3 bar, and this is vector R1 bar.